Assalamu alaikum, dear students. Welcome back to another lecture of structural analysis. In this lecture, we will discuss about an example and their solution based on virtual work method. In previous lecture, I have already discussed about an example and their solution based on virtual work method. But in my previous lecture, I have find the deflection of beam at any particular point on the basis of virtual work method. In deflection, we will apply one unit mean unit point load on that point in which we find the deflection. But now in this question, we will find out the slope of a beam. Okay, but for a slope, it is necessary to apply a unit couple movement on that point in which we are required to find out the slope. Okay. So now we are come toward the example number 9.8. Okay, this example basically I have chosen from R.C. Hebler book Structural Analysis. Okay, in this example I have given determine the slope at point B of the steel beam shown in the figure. Modulus of elasticity 200 gigapascal and moment of inertia is 16 to 10 power 6 mm power 4. Okay. In this question, I have given a cantilever beam. Now, what does it mean of cantilever beam? And cantilever beam, it means that one side is fixed, another side is free. Okay. Now, at free side, 3 kN point load is applied, and the total length of the beam is 10 meter, and the center point of the beam from this support is 5 meter. It is necessary to find out the slope at point B of this cantilever beam. So there is fixed support. Now what does it mean of fixed support? Fixed support means that there exists three type of loads such as vertical load, horizontal load as well as movement. So the load which is applied on the beam is provide anti-clockwise movement. So the movement will be, the reaction of movement will be opposite, mean clockwise direction. Okay. Now we will apply one unit couple movement on that point. Okay, so the slope at point B can be obtained by applying unit virtual couple movement. Here we take two coordinates x1 and x2. By section method we can find internal movement. Okay, now in this question we will apply at point B unit couple movement on point B. Okay, so here we take two sections along this point and along this point. Why we take two sections? Because there is two type of load applied. One is the movement, another one is the original load, point load, and this one is movement. Okay, so for this section we will separate this section from the free body diagram. Here you can see this is the x1, and if we take section, so here must be two type of reaction will be occur, such as shear forces and another one is movement. Okay, so here along this point the movement will be m theta 1, and in this point the movement will be m theta 2. This is the virtual movement which I can find. Okay, so m theta 1 is equal to 0 because there is no external load applied and external movement are not applied on this section. Now we take another section from a point to this place. Okay, so this section we separate from the free body diagram, which is x2 plus 5 meter. Okay, now we find the movement along this point. So summation of movement is equal to 0. M theta 2, which is anti-clockwise, we consider plus, and this movement is clockwise, we consider 1 is minus. Okay, so m theta 2 minus 1 is equal to 0, minus shifting by equality of sign, so will be m theta 2 is equal to 1k. Okay, now this is the two virtual movement which I have find. Okay, now we are coming toward the what is the real movement of this beam. Okay, we again take two section along x1 point and x2 point, and we will find two movements such as m1 and m2. Like I have find m theta 1 and m theta 2. This is the virtual movement, and now I am going toward the real movement. Okay, so there are two section and there is 3 kN load is applied. So we separate this section from the real beam. You can see here in this diagram, this is the x1 distance. At this point we will find the movement. Okay, So summation of movement is equal to 0. M1, which is anti-clockwise, we consider positive, and again this point will be provide clockwise movement. Okay, so 3 kN into x1, this is the perpendicular distance to 3 kN load. So this is equal to m1 plus 3x1 is equal to 0, and by shifting this 3x1 into equality sign of right side, so we will get m1 is equal to minus 3x1. Okay, this is the one real moment, and again we take section from this point to this. Okay, so this is 5 meter plus x2. Okay, now what we will do, we will find the movement along this point. Okay, so this point will be provide clockwise movement, and this load will be provide clockwise movement, but the distance, perpendicular distance from this load is x2 plus 5 meters. So 3 kN multiplied by 5 plus x2, this is one movement, and another one is m2, which is already anti-clockwise. So by shifting this value to the equality sign right side, so we will get m2 is equal to minus 3 into 5 plus x2. Okay, so this is the real moments which I have find. Okay, now what we will do, the next step of our example is that we will multiply these two moments, such as real movement and virtual movement, and take the integration of these two movements. Okay, so this is the product of virtual movement and real movement, and integration of from 0 to L. Okay, and 1 kilonewton load is also applied, 1 kilonewton meter load movement is also applied to point B. Okay, so theta B is equal to 0 to 5 virtual movement and real movement of that point, and then real virtual movement and real movement of this section. So after computing this, we will get the result is 112.5 kilonewton dot square meter. Okay, so after putting the value of EI, we will get the required answer of delta B, theta B. Okay, so there is the difference in unit. The numerator value is in meter and the denominator value in millimeter. So what we will do in this point, we will do same the unit. Okay, so we will convert this value as to meter. Okay, so by multiplying 10 power minus 12, we will get the whole answer in meter, but there is the value of theta. So if we same the unit, the result should be in the form of radian, because this is the theta. Now theta B is equal to minus 0.00938 radian. Now here the sign of this answer is negative. What does it mean? It means that negative sign indicate theta B opposite to direction of virtual couple movement. Okay, it means that we have applied the load in clockwise direction, but the deflection at beam is like that. Okay, opposite to this unit couple movement. Okay, so now what is the conclusion of my example? In this example, I have given a cantilever beam, and there is 3 kilonewton load is applied. The distance of beam is 10 meter, and the modulus of velocity is 200 gigapascal, and moment of inertia is 60 and 10 power 6. Okay, mm power 4. Then what will be the next step of our example? Next step is that to find the slope at that point. So then the slope of point B is minus 0.00938 radian. Okay, so I have solved this question in detail. If you have any question, if you have any issues related to this question or related to structural analysis or virtual work method, so you can feel free to ask me and comment. Thank you.